Welcome. Today we're going to dive into this sort of hidden world of engineering. It's something that shapes, well, pretty much everything, from your morning coffee to your commute home. We're talking about the science of making things work better.
So let's just start with a question you've probably never asked yourself. Can you actually engineer a better grade? I know, it sounds a little weird, right? Engineering is for bridges and software, not for test scores. But what if the exact same logic that builds a super efficient factory assembly line could also build a super efficient learning experience?
Okay, so the problem really starts right here. In any classroom, things can start to go off the rails long before anybody sees a bad test score. See, when a teacher's actual pace starts to drift away from the planned curriculum, even just a little bit, students start to get these learning gaps. And the real kicker? These gaps are pretty much invisible until it's way too late.
So why is this huge problem just hiding in plain sight? Well, for years, schools have been relying on these super slow, paper-based audits. Just imagine trying to steer a giant ship, but you're only allowed to look at the wake it left, like 3 miles behind you. You're constantly playing catch-up.
This is where the whole game changes. The old way is totally reactive. It's just a history lesson of what's already gone wrong. But this new approach completely flips the script. It uses a digital tool to watch progress as it's happening, in real time. It basically turns a dusty old archive into a live, dynamic dashboard.
So, what does this actually look like when you put it into practice? Well, an innovator by the name of Chingombe Shitati engineered an automated curriculum tracker. Now, this isn't just about scanning paper and putting it online. No, this is about building an intelligent system that can actually see the future of a student's success or their failure.
At the heart of this whole system is this metric with it's a mouthful of a name, the curriculum coverage gradient. But don't worry, it is way simpler than it sounds. Just think of it like a performance score for pacing. It mathematically compares what was supposed to be taught with what was actually taught, and then it just spits out one single, really clear number.
And here's the magic of how it works. It's a simple 3-step loop. First, teachers pop in their weekly progress. Second, a program instantly crunches the numbers and calculates that efficiency score. And third, and this is the important part, the system automatically flags anyone who's falling behind. It's basically an early warning system for those learning gaps.
And you know what? It all comes down to this one number, 85%. Think of this as the data-driven tripwire. If a teacher's score dips below this line, boom, the system sends an alert. It's not about someone's opinion or feeling. It's a clear, objective signal that a student's education might be at risk.
Now, of course, no system is a perfect silver bullet. The advantages are huge, right? You get real-time intervention, you get rid of manual mistakes, and you're always ready for an audit. But there are some hurdles. It does take a little bit of technical know-how, you need the right computers, and, like with any new technology, it can kind of feel like Big Brother is watching to the people who have to use it every day.
This whole solution to a classroom problem, it really points to a much, much bigger idea. A tool this elegant and this effective doesn't just appear out of thin air. It's the product of a very specific way of looking at the world, a powerful discipline for just making things better.
And that discipline, it actually has a name. We've just seen how it works inside a classroom, but its reach is so much bigger. So let's zoom out for a second and take a look at the science of making, pretty much everything better.
It's called industrial engineering. This is the branch of engineering that is all about optimizing complex systems. Or, to put it another way, these are the folks who make our world run smoother, faster, and smarter, whether that's in a factory, a hospital, or, even a classroom.
These right here are the core tools in an industrial engineer's toolkit. And if you look closely, you can see every single one of them in that classroom tracker we were just talking about. It treats the school like a system, it analyzes the flow of information, and it optimizes for one crucial thing, a quality education.
So, how do you even develop this kind of thinking? I mean, it takes a really unique kind of training. Let's take a little peek inside the program that's designed to create these master problem solvers. A doctorate in industrial engineering.
So the journey is this structured climb, and it's broken down into 4 phases. You start with the fundamentals, then you move into the really advanced stuff like systems design. From there, it's all about doing your own independent research on real-world problems, and it all leads up to this dissertation that's meant to be a genuine contribution to the field.
What's really cool is the philosophy behind this whole program. It's built on a concept called andragogy, which is just a fancy word for a really simple idea. You treat adult learners like, adults. The program trusts students to direct themselves, to use their own professional experience to find and solve problems that actually matter to them.
So the end goal here is to create a totally new kind of leader, someone who's a master of optimization, a critical thinker who can untangle these massive, complex global systems, and an innovator whose work makes a real impact out there in the world.
So, what's the big takeaway from all of this? This way of thinking isn't just for academics or engineers in a lab. It's actually a lens, a new way you can look at and see the hidden systems that are running your world, from your daily commute to your entire career.
You know, this quote from the source material really just nails it. It perfectly captures the whole spirit of this field. The goal isn't just to write some long paper, it's to create something new that adds real value, that solves a real problem, and that contributes to our collective human knowledge.
And I promise you, once you know what to look for, you are going to start seeing it everywhere. That surprisingly efficient layout at the hospital, the smooth flow of a factory floor, heck, even that super fast checkout line at the grocery store, that, my friends, is industrial engineering in action.
Which kind of brings us to one last question for you. From your morning routine to the workflow at your job, what system in your life is just crying out for a better design? What part of your world is just waiting for you to become its engineer?